All right, so complex numbers over the form. So here we say z is a complex number. It has a real part. I'm going to call this the real part, or we shorten this with real, re part, and this is the imaginary part, im. So we have the real and imaginary part right on this layer. And so A is the real part, we call B the imaginary part. It is important to note that the imaginary part doesn't include the I. And so the imaginary part, well, it's what's next to the I. When we actually ask for that, it doesn't include the I. And so let me explain that. It's easier to explain. So here we have a complex number, right? 5 plus 3i. The official definition of what I is I squared equals -1. So that's the official definition, is I squared equals -1. What we usually simplify it to is this: the square root of -1 is I. This is technically more correct. Technically more correct. But for all intents and purposes, you can assume this, right? And so the reason we introduce this is it allows us to solve any polynomial. That's the reason it really came about. So here we have a complex number. It has, and the real part here, so the real part here is 5. The imaginary part here is 3. And so it's what's next to the I, but not including the I. So that's important to know. I don't think I'll try to trip you up on that, but I just want you to be clear on that. I don't think I'll actually make what's the real part, what's the imaginary part. No, I actually might ask you that and just don't fill in the I because that'd be incorrect. For a number, yeah, I think I'll ask you that, but it'll be a later problem. So I'll show you when we get to it. Hold on, let me pull up something real quick. All right, so here, the imaginary part for this one is 3.1. What's the real part? Well, the real part is technically the 0 plus the 0.31. So the real part here is 0, so it doesn't have a real part. Now, if I see this, the real part here is 3/2. The imaginary part here is 1. And so you actually will have to simplify in order to tell what's the real, what's the imaginary. Okay. So going on, so here's a really fancy formula definition. It says if when you're adding or subtracting imaginary numbers, you add like parts. And so basically the C's will get added together. So the real parts get added together. So A and C represent the real parts, so these get added. B and D represent the imaginary part, they get added. And it's the same thing for that. So basically it's kind of like they're like terms, right? So the imaginary are like terms and the real are like terms. And so it's like kind of if you add X polynomials where you have X squared, X cubed, and all that, you can only add the X squares to X squares. Here you can only add the imaginaries to the imaginaries. So when we do that, this will be, if I add these two imaginary numbers, it'll be 2 plus 6. So that's my real part, plus 3 minus 3i. So it'll be 3 minus 3i. So this would be 8 plus 0i, and so this just ends up being 8. Here, I'm going to distribute the negative, right? And I can also distribute this negative in if I wanted to. So this becomes minus 3 plus 3i plus 2 minus 4i. And so after I do that, I can add the real parts. My real parts is -3 and 2, so that gives me -1. My imaginary parts are 3 and -4, so that gives me -1 as well. And so that's how I have that. Now here, if we have more than one of each one, so we can just do the real parts together. So it'll be 3 plus 6, which is 9. I have a -2i and a +2i, so those just cancel each other out. And so I'll get a +7i. And so when you're adding and subtracting, just do like terms. All right. So powers of I. So I to the first power is I to the second power is -1 by definition. I to the third power is minus I. And the reason that is because here if I have I to the third, I can write this as I squared times I, where I squared, of course, is -1, so it'll just be minus I. And if I have I to the fourth, I can write this as I squared times I squared. And by definition, this is -1 times -1, oops, times -1, which of course is just 1. And then here, if I have I to the fifth, I can just rewrite this as I to the fourth, which I know to be 1 times I, which gives me, well, this is 1, this is 1, this is I, so this gives me I. And so it just kind of goes in the cycle over and over and over and over again. And so if I gave you some really large power of I, you can always quickly tell what this is. Well, this is equal to I to the fourth times I to the fourth times I. And so what would this end up being at the end of the day? See if you guys get the song and dance here. What is this one? What's I to the fourth times I to the fourth of the I? Yeah, just I, because here, this is 1, this is 1, and this is just I. Okay, so let's do something a little bit more complex. And so let's do I to the 47th. And so I to the 47th, well, if I take 47 and I divide it by 4, I'm going to get 1, 0, 1, 3. So I have a remainder of 3. So I'll have, this is equal to I to the fourth to the 11th power times I to the third. Well, I to the fourth to the 11th power, this is 1 to the 11th power, so it's just 1. And I to the third here is negative I. Here for I to the 0, anything to the 0 power is of course 1. Or if I walk this backwards, you actually can reproduce these numbers. And so you'll get a 1 if I went backwards on my little chart. So here, no matter what I give you, say if I give you I to the 120 power, you should be able to tell me what it is. You just divide this number by 4. So 120 divided by 4 is, of course, 30, right? Remainder 0. And so here I'll have I to the 4th to the 30th power, and then nothing. So this is just equal to 1. And so no matter what number I give you, could we have just done I? Yeah, so you could have, for A, you could have just done that. The reason I showed you A in this order because then I can generalize it to any size. So yeah, so no matter what number I give you, you can tell me what I is. It's just I mean, it seems like a fun little math game, but it allows you to be comfortable with I in the imaginary unit a little bit better, and it allows you to have high powers and instantly know what to do. You'll see probably like one multiple choice question on this. So I'll give you I to some number, and then I'll say A will be I, B will be negative I, or A will be I, B will be -1, C will be I minus or negative I, and D will be 1, and you just pick it. All right. So let's talk about multiplying complex numbers. Here's a really fun formula you can use. I'd never use this formula. I mean, yes, you do this, but notice here that this I squared just becomes negative, and so you have AC minus BD because it's negative, and then these are your two row terms. Let me just kind of show you how it goes down real quick. I'll use the formula one time, and then I'll not use the formula the next time, just to show you how things work. All right, so here, if I was going to multiply these two numbers, I'm going to do, so we'll do first. So it'd be 2 times 6, which is 12. Inside, I think. Is it is it first? I don't know how to spell foil. No, it's the other way around. So let's do outside, which would be O2. So 2 minus 2 times this would be minus 6i. Inside would be plus 18i. So these two, negative 3i times 6, and then plus last would be 3. Would be minus 9i squared. Okay. So you always use I to the fourth? Yeah, so when I do this, I always use I to the fourth because that's a 1. So I just get to the nearest 1 and count from there. Just how it makes life easy. All right, so here we foiled. And we get this, and then we just simplify from here. This, of course, is negative 1, and so I plug that in here, so this just becomes positive 9. And so here, 12 plus positive 9 is 21, and then negative 6i plus 18i is plus 12i. Here, we can't really use the formula, we just multiply 3i times both of this, and so 3i times this will become 3i times negative, so 3 times negative 3 is negative 9 times I. 3i, I'll just go ahead and do the 2 steps. So 3i times 4i would be plus 12i squared. But remember, I squared is negative 1, so it would be minus 12 minus 9i. And the reason I swap order, that way we would just write it where the real and imaginary parts first. Okay, now here if I have a cubic, what do? Well, I can just write this as 2 minus 3i, 2 minus 3i, and then 2 minus 3i. We'll do the first part. And so the first part here would be 2 times 2, which gives me 4. This would be minus 6i, minus 6i. My dyslexia is not going to give me here because if I do outside, inside and outside, I get the same answer. And then negative times negative would be plus 9i squared. And we're going to multiply all that still by 2 minus 3i. We haven't done that yet. Let's go ahead and simplify this down. This becomes negative 9. And this becomes negative 9 plus the 5. So this will be minus 5 minus 12i. The 2 6i's give me a 12i. And then here we have 2 minus 3i. We FOIL one more time. So 2 times 3 is giving me minus 10. Outside gives me minus 15i. And then the inside gives me minus 20. Oh, no, negative and negative gives me positive. Negative and positive gives me, and then we'll have negative 12 times 3 would give me positive 36i squared. I didn't leave myself enough room. So this I squared makes this negative, so it'll be minus 36 minus 10, so it'll be minus 46. And then we'll have negative 24 plus 15i, so that'd be 9. Okay, that makes sense how to do all that. Multiply, subtract. It's just crunching numbers and doing things. Yeah, okay. All right, let's talk about complex conjugate for a second. All right, so complex conjugate. So complex conjugate is basically you negate whatever the imaginary part is. And so here, the complex conjugate, which would say by z, we just take, if it was negative, we make it positive. And if it was positive, we make the imaginary part negative. We don't change the real part. And the reason we do this, the main reason we do this is because we want, if I multiply a number by its complex conjugate, it becomes real. And that has very useful properties, which we'll see in a second. Here, there's no real part, but there's still we can still make the conjugate by just negating this. Now, if I ask what the complex conjugate, let me just put D here real quick. What's the complex conjugate of 5? Well, it's just 5. So If there is no imaginary part, it's its own conjugate because there's nothing there. And I'll show you why we use that. And it is right here. So when we're dividing complex numbers, the easiest, the nice way of doing this operation is to multiply by a complex conjugate, and then it makes things simpler to go down. And so let's go through this. And so here, if I wanted to perform the given operation, I want to do this divided by this. Well, how do I do that? Well, I kind of write it as a fraction. Then I'm going to multiply both top and bottom by the conjugate. Now, why can I do this? Well, it's because this is, it's because this is really 1, right? Something over itself is 1. And so I can do this. What happens to the bottom? Well, here, if I have 1 times, let me just do this slowly. So 1 times 1 gives me 1 squared. I'll have plus 2i minus 2i, so that equals 0. And then I'll have minus 2i squared. So this would be, I'll actually write it out. So this would be plus 2i minus 2i, and then it'll be minus 4i squared. Well, these, of course, cancel. This turns this into a positive number, right? And 1 squared is just 1, of course. And so this all ends up being, at least on the bottom, 5, right? Now we just multiply these two numbers together. So I'll have 3 plus 6i. The inside will give me plus 5i. And then I'll have plus 10i squared. So this 10i squared becomes negative 10. And so 10 plus 3 gives me minus 7. And then I'll have plus 11i. And so if I was going to write this out, I'll have minus 7 over 5 plus 11 over 5i. And so this is probably the exam question I'll give you. I'll ask what's the real part, what's the negative part? Well, this is my real part. Negative 7/5. And my imaginary part is negative 11/5 without the I. Okay. And so that's how you do that. And once again here, I'll just show you real quick. If you only have an imaginary unit on the bottom, the complex conjugate's the negation of that. And so you just multiply by the conjugate here. So 4 and that gives me minus 28i plus, oops, sorry. Yeah, it's a little aggressive. A little aggressive. 28 plus, or so minus 12i squared, but that becomes positive, so it'll just be 28i. I got rid of my I, grab it right back. Plus 12, all over negative 4 times 4i squared. So that simplifies out to be 12 minus 28i all over 16. And if I simplify that, you'll have 3 over, oops, yeah, so here I'll have 3 over 4 minus 7 over 4. Okay. So there's your real part, here's your imaginary part. All right, so there can't be imaginary numbers on the bottom. So there can, but you haven't finished the operation. Because if I ask you what's the real and imaginary part and you have an imaginary on the bottom, you don't know what the real or imaginary part is at that point. The second I get, not only do I get it down to a real, so it's a single real number, and then once a single real number, I can safely divide the real, because the real part will need to be real. The imaginary part, while it's a connected to I, is real, so real over reals you know how to do. So that's how you'll be doing this. You'll have a couple practice problems to do that. This will probably be your quiz question at the end of the day. All right, the last thing we need to go over is square roots of negative numbers and what to do in what order, because it matters. It legitimately matters. Okay, so here, so if we have this, we simplify it to here. And let me explain why that matters that we do this and do it this way and not the other way, because if we do it the other way, we get different answers. And so here, I need to simplify. So the whole point of introducing these things, so I can solve these, but let's do some operations with it. And so here, this becomes 2 square root 2, or I square root 2 times I square root 3. And I multiply these two together and I get I squared. Oops. I get I squared square root 2 times square root 3. Now I can do this operation. Well, I squared is of course negative 1, and square root 2 times square root 3 is the square root of 6. Notice if I just multiply these two together, I would get just square root 6, right? Because the negatives will cancel, and that is wrong. So always, always, always convert to imaginary units if you have a negative in your thing in order to prevent you from doing something which is incorrect. Okay, here, let's go ahead and do this one. So here, let's go ahead and simplify this down as much as I can. So what's this? This is, of course, 2 square root 3. I'm just simplifying right now. This becomes I square root 3. This is 3, we'll just say 3. Here, this will be plus, we'll make this I square root 4, but I square root of 4 is just 2, so we'll just go ahead and write that. And now I have this. Sorry. Now that I have this, I now can perform. And so here, actually, I can make my life easier. Since I have a square root of 3 and a square root of 3 here, I'll just pull it all the way out. So here, I'm just going to write square root of 3 of 2 minus I, 3 plus 2I. And then when I FOIL this, this is all the much easier. So make your life easier if you can. And then we'll have 2 times 3, which gives me 6 minus 3I plus 4I minus 2I squared. So that becomes plus 2. So that equals the square root of 3 times 8 plus negative 3 and 1, give me an I. And there you go. And if I finish that off, it would be 8 square root of 3 plus square root of 3. All right, so hold on. So when do you have to add the plus? When do you add? Hold on. Can you show me how to get two different fractions in the end? Yes. Oh, so this one? This is what you're talking about? Sorry, I haven't played it. I'm looking at the chat now. Yeah, okay. Okay. So here, let's break this down simpler. All right, so here we have 12 minus 28I all over 16. If I have a common denominator, if I have a single denominator and terms in the numerator, I'm allowed to write this as 12 over 16 minus 28 over 16I. Everyone okay with this? This is just one of your fraction rules. You guys go with those fraction rules? And so once I do that, then I can just simplify from here. Here, I'll simplify, take out a 4 on both, and so I'll get a 4 and a 3. And I'll take out a 4 on both here, I'll get a 4 and a 7. And that's how I got to that. So yeah, so that's how I got there. Sorry. All right, and what's the next thing? When do you have to add the plus minus thing? Oh, yeah, I'll show you when we do that. I know what you're talking about. That's when we solve these things. I'll show you when we do the plus minus thing. All right, so let's answer the next question. So here, let's pretend we're doing this right here. So here we have, so let's solve the following. So if I wanted to solve this, this would be x squared equals -4. Well, when I take the square root of both sides, so if I take the square root of both sides here and here, this just becomes x. When I take the square root is when I add the plus minus thing. So this is because, and the reason we add the plus minus here is because if I had negative x squared, it's the same thing as positive x squared, right? And so that's why we add the plus minus to signify we actually get two different answers. So we have plus minus the square root of -4. Well, that's just the same thing as x equals plus minus -4, pull out the I, so this would be I square root of 4. Well, the square root of 4 is 2. Okay. And then we probably write this the other way. I'll make this erase, I'm not supposed to do large. So it'll be 2I. So the plus minus one is when we take square roots of both sides. All right, so here we have another one. So can I factor this? No, right? Because the only factors I have here are 1 and 5, right? Or -1 and -5. And neither of those can add up to 4, so I have to use the quadratic formula. So here, if we crunch it through the quadratic formula, so -b plus or minus the square root of b squared, which in this case will be 4 squared minus 4. A in this case is 1, B in this case, or C in this case is 5, all divided by 2A. 2 and A in this case is 1. You guys have this memorized, that is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. You guys have that stuffed away in your heads? Yes. Apparently, somehow, some way, they like now do it to like Pop Goes the Weasel song or something. I haven't heard that, but my students have. So that's how I remember it. Oh, yeah, they do. Fair enough. All right, so when we get it to this point, what happens when we simplify everything down? So we have x equals -4. This becomes plus or minus the square root of -4 all over 2. Well, here, and so this becomes x equals to -4 plus or minus 2i all over 2. And then we'll just break that apart. So I'll get -2 plus or minus I. Okay. And one thing you'll notice here is that if I have polynomials of real coefficients, so if they're polynomials of real coefficients, so both of these have real coefficients, the complex number so they'll come, so complex numbers, so complex roots or zeros, whatever we want to call them, come as a pair of conjugates. So they always will come as a pair of conjugates. So you'll either we'll have plus or minus I, and so it always comes out that way. So if you don't have conjugates and you had real things, you did something wrong. Okay. All right, so that's all our notes on complex numbers.